With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is, which of the following assumptions of the kinetic molecular theory best explains the observation that a balloon collapses when exposed to liquid nitrogen, which is much colder than a cold winter day? Right, so in this question, four kinetic molecular theory assumptions are given, and we have to find out which of the following assumptions is the best explains the observation that a balloon collapses when it is exposed to liquid nitrogen, which is much colder than a cold winter day, right? So let's see. So basically the main reason behind that a balloon collapses when exposed to a liquid nitrogen is that liquid nitrogen is very much colder than a cold winter, which means that its temperature is very much less, right? Temperature is very less, right? And we know that kinetic energy is equals to the 3 by 2 RT, where R is the universal gas constant, and T is the absolute temperature of the gas, So from here it is clear that kinetic energy is directly proportional to the absolute temperature of the gas, which means if we decrease the temperature, kinetic energy will also decrease, and due to which the balloon will get collapsed, right? Now coming to the assumptions. So first assumption is that gas molecules move at random with no attractive forces between them. So basically this assumption is completely right, that gas molecules move at random with no attractive forces between them. We know that in a container gas molecules move in random motion and collide with each other without any attractive force, but this assumption is not explaining the given observation, so we will not consider this one. Now moving to the second assumption, the velocity of a gas molecule is proportional to their Kelvin temperature. So this assumption is also completely right, and it is said that the velocity of a gas molecule is proportional to the Kelvin temperature. We know that kinetic energy is also equal to the half mv square, right? And we have also seen that it is equals to the 3 by 2 RT. So from here it is clear that velocity of molecules of gas is directly proportional to the temperature. And one more thing, we know that RMS velocity of gas molecules is equals to the square root of 3 RT by m. So from here we can conclude that the velocity of gas particles is directly proportional to the Kelvin temperature. So this assumption is completely explaining the given observation, so we will consider this one. Right, now moving to the third one. The amount of space occupied by a gas is much greater than the space occupied by the actual gas molecules. So basically what happens, this is the container, right? And this is the volume occupied by the gas, and this is the volume occupied by the actual gas molecules. So it is clear that the volume occupied by the actual gas molecules is less than the volume occupied by the gas, right? So this assumption is also right, but we will not consider this one because it is not explaining the given observation in the question, so we will not consider this one. Now moving to the last explanation. Collisions with walls of the container or with other molecules are elastic. So this assumption is also completely right, that collisions with the walls of the container and with other molecules are always elastic in nature according to the kinetic molecular theory. But this assumption is not explaining the given observation. So So out of the given 4 assumptions, the assumption that is best explaining the given observation in the question is assumption 2, that is the velocity of gas molecules is proportional to their Kelvin temperature. So this is the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.